Good morning. Good morning all. Screen is visible?
Yes, sir.
Yes,
Sir.
So all of you got the message of class test 1 on halogen derivatives. The
Yes,
test
sir.
will be conducted
Yes, sir.
on Monday. Monday already it is a holiday, remember. So exactly at 9:30, the link will be open. Already I have sent the email. So the test will be proctored examination. We have to access your camera and microphones. Not all the students I want access. So particularly if here in the system, if I got the doubt, then I will ask to the access. This access will not for all students, remember. If I want to check anybody's how he is or she is writing the examination, then I can ask the access, remember. So don't worry
Sir,
about
Saturday ला Monday ला आहे?
Saturday la.
Saturday ला का Monday ला टेस्ट?
मंडेला मी मेल पाठवलेला आहे बघा 16 ला मेसेज पण दिलेला आहे मी ऑलरेडी आय हॅव गिवन द मेसेज ऑन द ग्रुप ऑल्सो बिकॉज सम स्टुडंट्स कॉल मी सर वी डिडंट प्रिपेअर फॉर द एक्झामिनेशन सो आय हॅव गिवन 2 days extra and also I want to do the announcement of the second class test. It will be conducted on the chapter alcohols, phenols and ethers. Examination will be same for 25 marks. 25 MCQs will be there, and it will be also the proctored examination. If you pass the exam, then you will get the certificate. Otherwise, again we have to repeat the examination. So all the tests will be auto generated. The time limit is also there. If the time is completed, the test will not automatically submitted. We have to submit it, remember. We have to submit it, but here I will get the message, this and this student who submitted the late examination. So these are the some instructions regarding the online examination, and all these marks will be considered as internal marks, remember. If last year due to the COVID situation, the board do not conduct the examination. So the evaluation was done on the basis of internal marks. So these internal marks are very important, remember. So prepare very well. Best of luck for your examination. No any theoretical question is there, but the questions will be on the application base. The questions will be on the application base, remember. I think in this chapter, methods of preparations of carboxylic acid
Sir,
completed. Yes.
sir, rough book allowed hai paper ke time.
Rough book is allowed. You can do your rough work on your notebook, but we have to submit the photographs of rough book also to me.
सर म्हणजे ते कॅमेरा समोर असं ठेवायचं ना.
हो, ते कॅमेरा समोर ठेवायचं. ठीक आहे.
ठीक आहे.
I
Okay,
want
sir.
that rough book also. I want that photographs. ठीक आहे. So any doubt regarding the examination, tell me.
नाही होणार ना सगळ्यांचा ऍक्सेस नाहीये ना कॅमेरा आणि
सगळेच
माईक.
ऍक्सेस नाहीये. मी इकडून ज्याला ऍक्सेस मागेल ना त्यानेच ऍक्सेस द्यायचे.
मग सर दाखवणार कसं रफवर?
तुम्ही मला फोटो काढून पाठवायचे व्हॉट्सअपला पर्सनल प्रत्येकाने.
बर सर. हो.
ठीक आहे. Whatever the work you have done,
Okay, sir.
You have to send me the photographs personally.
सर फिजिकल प्रॉपर्टीजवर पण असणार का क्वेश्चन?
असू शकतात. म्हणजे ऍप्लिकेशन बेस असेल त्याच्यावरती काय प्रश्न असतो समटाइम्स रिमेंबर मेल्टिंग पॉइंट आणि बॉइलिंग पॉइंटचा प्रश्न असतो. यु नो ऍज द सरफेस एरिया इन्क्रीजेस व्हॉट हॅपन्स?
बॉइलिंग पॉइंट
increases, and if the branching increases melting and boiling point decreases. याच्यावरती क्वेश्चन असतो कारण हे सीईटी बेस क्वेश्चन असतील सगळे, लक्षात घ्या. ऑल द क्वेश्चन्स विल बी सीईटी बेस. ठीक आहे, म्हणजे सीईटी ची पण तयारी होऊन जाईल ना तुमची, वेगळं त्याच्यासाठी करायची गरज नाही. हा, तर आता मी येऊ का चॅप्टर कडे परत? अल्डिहाइड
Can you send sample question? Sample question पाठवू शकता का?
सॅम्पल क्वेश्चन बर ठीक आहे, पाठवतो मी आज तुम्हाला सॅम्पल क्वेश्चन कसे असतील. ठीक आहे. फॉर एक्झाम्पल सांगू का? विच ऑफ द फॉलोइंग इज ऑप्टिकली ऍक्टिव्ह कंपाऊंड? 4 compounds will be there. For example, glucose is there. For example, water is there. For example, 2-chlorobutane is there. So we have to choose which is optically active. For example, how will you convert the given reactant into the product? So their reaction will be given and we have to identify the reagents. So 4 reagents will be given, we have to choose one. So the questions will be not very difficult, but we have to think on the questions. Okay, direct answer you cannot get, we have to think over it. Which of the following
सर
is bolo
सर ते म्हणजे तिथे जसं तुम्ही पहिला क्वेश्चन सॉल्व्ह केला मग तिथे खाली सेव्हचं वगैरे ऑप्शन असणार का? ऑटो सेव्ह होत नाही ना?
क्लिक करायचं फक्त तुम्ही नुसतं. ओनली वी हॅव टू क्लिक. ठीक आहे, वी हॅव टू क्लिक अँड बिफोर सबमिटिंग. बोला बोला.
कादंबरी वाजे जॉईन करते पण तिचं जॉईनच होत नाहीये, रिमूव्ह करतायत तिला.
एक मिनिट, कुठल्या नावाने जॉईन होती तिला म्हणाव?
कादंबरी वाजे.
एक मिनिट हा, मी बघतो. कादंबरी आता आहे का याच्यामध्ये? कादंबरीला म्हणावं तुझं नाव आणि नंबरने जॉईन हो. मेसेज कर तिला. दुसरं नाव असेल तर मी ऍक्सेप्ट करत नाही म्हणावं तिला. राईट युअर वी हॅव टू राईट युअर नेम अँड सीट नंबर, रोल नंबर. नाहीतर मी रिमूव्ह करून टाकतो इकडून. नाहीतर दुसरे कोणी पण येऊ शकतं ना लेक्चरला आपल्या. ठीक आहे, तिला म्हणावं तुझं नाव आणि सीट नंबर टाकून जॉईन हो. ठीक आहे. एनी डाऊट रिगार्डिंग द एक्झामिनेशन?
नो सर.
ठीक है, now we will start the remaining part of this part. Already we have completed whatever the screen you are watching. This is oxidation. This is oxidation of alkyl benzene. So this is the toluene can be oxidized by using strong oxidizing agent. We get intermediate, and intermediate after acidic hydrolysis we get benzoic acid. So this is very good method to convert alkyl benzene into benzoic acid. Here we can convert the toluene also, we can convert the ethyl benzene also, we can convert the propyl benzene also. So whatever the alkyl group is there, it will be directly converted into benzoic acid, remember, by using this strong oxidizing agent KMnO4, or we can use CrO3. The entire alkyl chain without changing its length is oxidized. This is very important. The entire alkyl chain is oxidized without changing its length. Its length means carbon are not reduced. Whatever the carbons remains as it is. See here, here is one carbon, it will be COH. Here is also one carbon, it will be COH. But these two CH3s will be oxidized. Remember here, this carbon will be remains as it is, the central carbon. Tertiary alkyl substituents on benzene is not oxidized. Remember why? Anyone can tell me? Tertiary alkyl substituents on benzene is not oxidized. Anyone can tell me the reason of this?
सर त्याला बेन्झिलिक हायड्रोजन नसतं.
Very good. Very good. Very good. I got the answer because there is no hydrogen attached. Here is hydrogen is attached. Here is one hydrogen is attached. That's why it will be oxidized. If there is no hydrogen, it will be not oxidized. So this is the reason tertiary alkyl substituents on benzene is not oxidized. So by using alkenes also we can convert this to the benzoic acid. Styrene, you know, I think this is explained last time. So this styrene can be converted into benzoic acid, cyclohexene can be converted into adipic acid. So there is a oxidation of alkenes by using KMnO4 in presence of dilute H2SO4. Then this primary alcohols, also we discussed this reaction in the chapter alcohols, phenols and ethers. Alcohols on oxidation gives aldehydes and aldehydes on oxidation gives carboxylic acid. So one step we can also do by using strong oxidizing agent. And if I want to prepare aldehyde here, which oxidizing agent I have to use? Alcohol to
CrO3.
alcohol to aldehydes. I want to prepare aldehydes only. Here, instead of carboxylic acid, if, which one?
Cr2Cl3.
No. Mild oxidizing agent we have to use here. Which mild oxidizing agent? I have given the examples. Primary alcohols on oxidation gives aldehydes. But tell me the oxidizing agent. PCC. Remember, pyridinium chlorochromate, if it is used, we get here aldehydes. But if instead of PCC, if you use this KMnO4, it is the strong oxidizing agent. Also, we can use this K2Cr2O7 and also one reagent. This is very important for the CET. CrO3 in presence of H2SO4, it is called a Jones reagent. For JEE examination, also one question is asked on this Jones reagent. Jones reagent is the combination of CrO3 and H2SO4. So it is not given in your textbook. CET, JEE, NEET, this Jones reagent is also important. So you can use for the oxidation of primary alcohols to the carboxylic acids. These three reagents we can use: KMnO4, K2Cr2O7, CrO3 plus H2SO4. But here, KMnO4 in acidic or alkaline medium we can use. But for the K2Cr2O7, we have to use acidic medium. And for the CrO3, we have to use acidic medium. See, the detailed explanation is given. In the first step, we get here aldehyde, and further oxidation, we get here carboxylic acid. So this is already completed. And this is also very, very important for the board examination. So IMP already I have written here. In the right corner, I have written IMP. This question, this reaction is very important. Many times it is asked for the board examination. So what is this reaction? This is the reaction of Grignard reagent with dry ice. Dry ice, it is also called as solid CO2. So all of you know about this Grignard reagent, RMgX plus, this is a solid CO2. This is solid CO2. It is also called as dry ice. You know the condition. Dry ether we have to use. Now tell me which is charge present on R group. This is the delta minus. So X is also having the delta minus charge, and Mg having the 2 delta plus. So this, it will be attacks on this carbonyl carbon. The electron density will be shifted. It becomes O minus. It becomes O minus, and it will attacks on this Mg. So first step we get here intermediate. So this is the intermediate step. In the intermediate, this is a complex C. This is the complex or intermediate in which this R is bonded to the carbon. So we can see here this R is bonded to this carbon CO. This CO remains as it is, but the oxygen will be bonded to the MgX. This oxygen is bonded to the MgX. So this complex is again hydrolyzed in presence of dilute acid. This is acidic hydrolysis. We get here this entire group. This entire group, it is the leaving group. This is the leaving group. This, see the mechanism, HOH. This is a water. So how the reaction takes place? This oxygen having the lone pair, It will attacks again on this carbon. So entire group will be removed. So OH will be joined to RCO and it will be converted into RCOH. And this one hydrogen, it will be combined to this MgX and OH. MgX and OH. This is the byproduct, remember. This is the byproduct. Byproduct also we have to write at the time of examination. So you understand this reaction. This is a general reaction. And one example is given here, phenyl magnesium bromide. So here, this benzene will attacks here. We get the complex CO, OMGX, and this will be removed in the second step. We get here benzoic acid plus, this is the byproduct. This is the byproduct. Now, my question, if I have to prepare here acetic acid, if I have to prepare here acetic acid, which Grignard reagent I have to use?
सर सर आरच्या जागी इथेन इथाइल ग्रुप घ्यायचा.
ऍसिटिक ऍसिड प्रिपेअर करता येते का अगोदर बघा बरं त्याच्यापासून. CH3 ऍसिटिक ऍसिडचा फॉर्म्युला काय आहे? CH3COOH बरोबर ना. व्हॉट इज द IUPAC नेम? इथेनॉइक ऍसिड ना. COOH बरोबर आहे. I have to prepare this acid by using Grignard reagent. So this CO2
हे म्हणजे ड्राय इथर हे म्हणजे ड्राय आईस आहे का? ड्राय इथर म्हणजे ड्राय आईस CO2.
dry ether वेगळं, dry ice is different. Dry ice, solid CO2 is also called as dry ice. Dry ether we are using many times for the Grignard reagent. All the Grignard reactions are carried out in dry ether. You understand? All the Grignard reactions.
Yes, sir. Yes, sir.
Dry ether is different. Dry ice is different. Dry ether is solvent. Dry ice is reagent. Okay. So tell me, this CO2 will be remains as it is. We have to change this Grignard. So instead of phenyl magnesium bromide, we have to use methyl magnesium bromide, CH3 MgBr, CH3 MgBr. So we will get this acetic acid, CH3 MgBr. So this CH3 will attack. This CH3 will attack here. We get the complex CH3CO OMGX, and after hydrolysis we get CH3COH. You understand how this is prepared?
Yes, sir.
Yes, sir.
So, this is very important reaction. Remember, एक तरी क्वेश्चन याच्यावरती विचारतात. ठीक आहे. So write at least 4 to 5 times this reaction, and prepare different carboxylic acids here. Instead of benzoic acid, we can prepare ethanoic acid, we can prepare propanoic acid. So it is depend upon you how you are doing the practice of organic chemistry. We have to take here different examples, and these different
आपल्याला मिथिक ऍसिड फॉर्म करायचं, मग आर जागी फक्त हायड्रोजन घ्यायचं फक्त एक.
नाही ते प्रिपेअर करू शकत नाही आपण या मेथडने, कारण आपल्याला ग्रिग्नार्ड मध्ये आर पाहिजेच ना. So this is the limitation of this method. We cannot prepare here formic acid, or we cannot prepare methanoic acid. करू शकतो का methanoic acid prepare या मेथडने आपण? We cannot prepare because here this carbon is compulsory, and here in Grignard also carbon is compulsory. So 2 carbons are required. Okay.
Yes.
So examiner can ask or construct the question on it. What is the limitation of this reaction? They will mention the name of this reaction by using solid CO2, or they can prepare the sentence like this. In for the preparation of carboxylic acid and Grignard reagent, can we prepare the methanoic acid? True or false? True or false question can be asked on it, remember, for 1 mark. Okay?
Yes, sir.
This is homework for you. This is very interesting homework. This is not from your textbook, so we have to do this homework at your home. Answers are also given. Check your answers. So all the answers are also given, and this is given for your actual homework. How to convert this? Anyone can tell me what is the product of this reaction? CH3, CH2, Cn, and dilute HCl. This cyanide group. This cyanide group.
Sir, imine. Sir, imine.
काय होईल याचं? This is application based question. Remember, if you understand the reaction, then
Sir, ethanamine oil का?
no, this cyanide first it will be converted into amide, and amide again on hydrolysis we get carboxylic acid here. Here we get the final product CH3, CH2, COOH. CH3,
Aldehyde, no?
COH. No, this is method of carboxylic acid. This cyanide first step it will be converted into amide. See this reaction. I will show. Nitriles. See this reaction. Preparation of carboxylic acid. This nitrile CN is converted. First step is amide, and this amide. See, this is amide, and amides are converted into carboxylic acid. Here directly it is shown. See, amide to carboxylic acid. So understand?
Yes, sir.
Yes, sir.
This is application based questions. So this is NH2 again. It is amide. So what will be the product again here? CH3COH. This is a C6H5 ethyl benzene. Correct. C6H5 CH2CH3. Direct
Carboxylic acid.
benzoic acid. Very good. Direct we get here benzoic acid. Then C6H5CO C2H5. This is esters. Esters on hydrolysis, acidic hydrolysis gives carboxylic acid. Here also we get two products here. One is carboxylic acid and one is alcohol. See this reaction. See this reaction. One product is carboxylic acid. One product is carboxylic acid and one product is alcohol. Okay?
Yes, sir.
Then tell me these two reactions. How will we convert? Sorry, CH3 MgBr. Tell me the product. एक मिनिटात येतो. Yes, what is the product?
Sir, ethanoic acid.
Very good.
Acetic
ते
acid.
example विचारलं होतं ना मी आता तुम्हाला.
अभी आपने सर करके दिखाया.
हाँ अभी दिखाया था ना. ऐसे क्वेश्चन आते हैं बोर्ड एग्जाम को जो टेक्स्ट बुक में नहीं दिए और एक्सरसाइज में दिए, होमवर्क के लिए दिए. सो इसका प्रैक्टिस करो. ठीक है, ये भी प्रैक्टिस करो. इथाइल बेंजीन, वी कैन ब्रोमो बेंजीन, देन एसिटोफिनोन, स्टाइरीन. So all these examples are already discussed, but this is challenging for you. एसिटोफिनोन का ये आपके लिए चैलेंज है. एसिटोफिनोन का कन्वर्जन कैसे करेंगे कार्बोक्सिलिक एसिड में? This is challenge for you. Tell me, this is not very easy. This is two-step process. So इसका आंसर मुझे.
सर मग हे काय असतं सर? सायलिनिक म्हणजे काय असतं? सायलिनिक.
Which one?
सायलिनिक कंपाऊंड सबस्टन्स.
कुठले?
सायलिनिक.
सायलिनिक.
हा सर, म्हणजे तसंच काय तर आहे ते सायलिनिक काय तर आहे.
सॅलिलिक असेल सर. सॅलिलिक असेल.
हा सॅलिलिक ऍसिड.
कुठे इथं कुठे दिले? सॅलिसिलिक ऍसिड वेगळं रे. दॅट इज डिफरंट ऍसिड. याच्या रिलेटेड क्वेश्चन नाही का तो?
नाही सर, म्हणजे तसंच आहे. म्हणजे आता वेगळं कंपाऊंड आहे पण मला माहित नाही ते.
मग त्याची माहिती घेऊन मला जरा प्रश्न विचार ना. हे कसं आहे की जर त्याचं स्पेलिंग चुकीचं असेल तर ते वेगळा अर्थ निघतो त्याचा. हे दिस इज चॅलेंज. Acetophenone to carboxylic acid. This is not given in your syllabus. this acetophenone to benzoic acid. Anyone can tell me the reason, or any can tell me the answer of it? How will you convert this acetophenone to benzoic acid? घरी करायचा वेळ नका घालू.
दोन रिएक्शन मिक्स आहे का?
This is not one step. We have to do two-step reaction. So the next point is physical properties of aldehyde, ketones, and carboxylic acid. First, we will discuss the nature of intermolecular forces. So in this, in aldehydes and ketones, see, this is CO group is there. This is called as carbonyl group. It is polar covalent bond. This is polar covalent bond. Polar means this is separated. We can say this is the delta plus and this is the delta minus, because oxygen is more electronegative. So in case of CO, this CO is a polar covalent bond. Therefore, these compounds contain dipole-dipole force of interaction. These molecules orient in such a way as to have oppositely polarized atoms facing each other. In case of carboxylic acids, they contain OH bond, which is responsible for the formation of hydrogen bonding, correct? COOH, in which OH group is extra in case of carboxylic acid. So they are responsible for the formation of hydrogen bonding. So in case of carboxylic acids, having the stronger intermolecular force of attraction, and in case of aldehydes and ketones, there is no possibility of hydrogen bonding. But in case of carboxylic acids, there is a possibility of intermolecular hydrogen bonding. Harish, tell me.
सर आता हे हायड्रोजन बॉन्डिंग आहे ना कार्बोक्सिलिक ऍसिड मध्ये, मग सर ते मग वॉटर मध्ये सोल्युबल आहे की नाही? कारण की वॉटर मग हायड्रोजन बॉन्डिंग लागतं.
सोल्युबल आहे ना कार्बोक्सिलिक ऍसिड. येतो ना मी पुढे त्याच्या टप्प्यामध्ये, हळूहळू मी त्याच्याकडेच येतोय. वॉटर सोल्युबल आहेत का नाही आपल्याकडे पुढचाही काय टप्पा आहे ना, सोल्युबिलिटी अँड अल्डिहाइड कीटोन्स. आय एम कमिंग टू दॅट पॉइंट. So next point is physical state and boiling points of aldehyde ketones. So formaldehyde, first compound, it is a gas. Formaldehyde is a gas at room temperature, and it is also having the irritating odor. Irritating means very bad odor. It is very irritating. Acetaldehyde is extremely volatile. It is a liquid. Formaldehyde is a gas. Then it is extremely volatile. Its boiling point is very less. Colorless liquid. Higher aldehydes having the pleasant odor, other than acetaldehyde, as the number of carbons are increasing, though. So the smell is also nice. Higher aldehydes. In case of higher aldehydes, they are having the pleasant odor. Then I'm coming to the ketone. First one is acetone. It is a liquid at room temperature. It is also volatile. It is having the pleasant odor, but most of the higher ketones having the bland odor. What is mean by bland? Anyone? ओडरचा एक प्रकार आहे तो ब्लँड ओडर. आता ते बघा ब्लँड ओडर काय म्हणजे तो पण असा आपल्याला इट इज नॉट प्लेझंट. सो इन दिस टेबल सी the number of carbon atoms are here increasing 1 2 3 4 5 6 methanol, ethanol, propanol, butanol, pentanol. See the boiling point. What is happening to the boiling points? Tell me here.
Sir, increasing.
Increase.
Yes. And what about the ketones here? Increasing है ना? So as the number of carbon atoms are increasing, the boiling points of aldehydes, ketones are increasing. ठीक है? इसके ऊपर भी क्वेश्चन बना सकते हैं. एक देखो इसके ऊपर भी 1 मार्क का क्वेश्चन बना सकते हैं. So be prepare on this table also, but they cannot ask the values. They cannot ask the what is the boiling point of propanol, what is the boiling point of methanol. On the values, no any question will be asked, but on the trends question will be asked. On the general trends question will be asked. So these values are not important for us. These values. इसके ऊपर कोई भी क्वेश्चन आपको नहीं आएगा. ये values कौन नहीं पूछेगा? कौन सी भी एग्जाम में JEE भी नहीं पूछेगा, CET भी नहीं पूछेगा, बोर्ड भी नहीं पूछेगा. So forget the values. Then I am coming to the solubility part. What is the solubility? For the solubility, hydrogen
सर ब्रांचिंग अगर बढ़ गई तो बॉइलिंग पॉइंट डिक्रीज होगी ना?
branching, correct. If the branching increases, means surface area will be decreases, so the boiling point will be less. But here, all these are straight chain. All these are straight chain, methanol, ethanol, propanol. All these are straight chain aldehydes, and these ketones are also straight chain ketones, remember. ठीक है, यहाँ पे अगर branching increase होता है तो it will change, boiling point will decrease, remember, because surface area will decrease. Then the solubility, oxygen atom of this CO can involve in the hydrogen bonding with water molecule. So because of this feature, lower aldehydes and ketones are water soluble, remember. Lower aldehydes and ketones are water soluble. For example, it is given acetaldehyde, acetone. As the molecular mass increases, just we see here molecular mass is increasing. The proportion of hydrogen part of the molecule increases. So the hydrogen part will be increases, so which cannot form hydrogen bond. Therefore, the water solubility decreases. You understand what is the meaning of this one? As the molecular mass increases, so what will happen here? The proportion of hydrogen part in the molecule is also increases, which cannot form the hydrocarbon bond, and therefore water solubility decreases. As the number of carbon increases, water solubility decreases. The reason is given here. So here the hydrogen bonding in carbonyl compound and water. So this is a carbonyl compound. See carefully. This is a CO group. This is a CO group. Oxygen having the negative charge, carbon having the positive charge. This is water molecule. So this is water molecule, and see this is the bond between this oxygen and hydrogen. This is a hydrogen bond. But as the molecular mass increases, means as the number of carbon will be increases, hydrogen will be also increases. So the proportion of hydrocarbon part, the proportion of hydrocarbon part of the molecule increases, which cannot form the hydrocarbon bond. Which cannot form the hydrocarbon bond. So yeah, I think you understand this one.
सर ही कंडिशन फक्त ऍल्डिहाइड आणि कीटोन मध्येच आहे का?
हो,
ओके.
ठीक है. Then this is about the carboxylic acid, physical state, boiling point, and solubilities of the carboxylic acid. Lower aliphatic carboxylic acid up to 9 carbons. Up to 9 carbons, these are colorless liquids with irritating smell. Then higher acids are colorless, odorless, wax solids having the low volatility. Boiling point of the lower carboxylic acids are given below. Here are some boiling points are given. Formic acid having the boiling point 373. Acetic acid is 391. Propanonic acid is 414. Then N-butyric acid is given here. N-valeric acid is given 460. So what is happening here? As the molecular mass increases, boiling point is also increasing here. Now, this question is very important. Carboxylic acids having the higher boiling points than that of alkanes, ethers, alcohols, aldehydes, ketones, or comparable mass. So, if we consider the carboxylic acids, ethers, alcohols, aldehyde, ketones, so what is the condition? Carboxylic acids having the higher boiling point. So what is the reason is given here? The reason is that in liquid phase, carboxylic acid forms a dimer. So the example of dimer is given here. They form the dimer in which two molecules are held together by hydrogen bonds. So I'm showing how the dimer is formed. See this dimer, this is one molecule, CH3COOH, this one. This is one molecule and this is CH3COOH. This is another molecule. This is one molecule of acetic acid. This is another molecule of acetic acid. And we can see here, there is one bond. And here is also one bond. So this is a dimer of acetic acid in which two molecules are held together with hydrogen bonds. So due to this feature, carboxylic acids having the higher boiling point, that of alkanes, ethers, alcohols, aldehyde, ketones. Then the acidic hydrogen of one molecule, ये कैसे bond prepare होता है वो इसे दिया है, how the dimer is prepared. This double the size of the molecules, resulting the increase in intermolecular van der Waals forces. ये डाइमर फॉर्म होने के वजह से क्या हो रहा है कि साइज ऑफ द मॉलिक्यूल इट बिकम्स डबल्स एंड इट रिजल्टिंग इन इंक्रीज इन इंटरमॉलिक्यूलर van der Waals forces. एंड इसका इफेक्ट क्या होता है कि which results in high boiling point because of the dimer preparation. ठीक है. So acetic acid dimer exists even in the gaseous phase also, remember. So this is exception of acetic acid. In gaseous phase, it also shows the dimer. So in the chart below, we can see clearly this is alkane. See the boiling point. Molecular mass is comparative. Molecular mass is given. Alkane, see the molecular mass is 58. Here in ether it's 60. In aldehyde it is 58. So I think it is comparable. It is 58, 60, 60. So this is alcohol, ketones, and carboxylic acid. See, this boiling point is very high. This is the boiling point of alkane is 272, 281 for ether. Aldehyde is 322. So you understand what is the reason behind this, why the carboxylic acid is having the higher boiling point, because of the dimer formation. And this dimer formation is not possible in case of alkanes, ethers, aldehyde, ketones. So what is the moral of the story? Why the carboxylic acid is having the higher boiling points? Because of the dimer formation. And how the dimer is formed, it is shown. Okay. The
Yes,
next,
sir.
this is for your knowledge. No any question will be asked on this slide, remember. No any question will be asked on this side for the board examination. This is for your knowledge only. This is for your knowledge only. ज्यांना वाचायचे त्यांनी हे घरी वाचायचे. Okay. But it is explained. Very important information is given here. Strength of intermolecular forces. Which forces are very strong? See here, hydrogen bonds are very stronger than dipole-dipole interaction. And सबसे weak forces कौन से रहते हैं? Van der Waals forces. So here see the boiling points: carboxylic acids, alcohols, ketones, aldehyde, ethers, and alkanes. This is the sequence is given. Carboxylic acids having the higher boiling points because of the hydrogen bond. Strength of hydrogen bond is very strong. Then dipole-dipole interaction, and then van der Waals forces are very weak forces. So commercially available forms of formaldehyde and acetaldehydes are given here. Commercially, formaldehyde is available commercially as a solid polymer for paraformaldehyde and trioxane. This is for your knowledge. This formalin is very important because this formalin is an aqueous solution of formaldehyde gas, which is used for preservation of biological and anatomical specimens. We can keep the specimens for long time. Okay, formalin is used. When dry formaldehyde is required, it is obtained by heating paraformaldehyde or trioxane. This is trioxane is given CH2O3. This is a trioxane. And acetaldehyde is also conventionally used as a solid trimer and tetramer. So this is for your knowledge purpose only. You must know, for the knowledge it is given. So no any question will be asked for the examination. Okay. Then solubilities of carboxylic acids are explained in this slide. Solubilities of the carboxylic acid. So only 1 minute is remaining. Lower aliphatic carboxylic acids containing up to 4 carbons are miscible with water due to the formation of intermolecular hydrogen bonds with water. The solubility of carboxylic acids in water decreases